Okay, so as I was saying, gamma squared is equal to 1 over 1 minus beta squared. So when you multiply that by 1 minus beta squared, you get 1. And so we find that delta S squared is equal to 2L squared. And if you look at what we had on the previous view graph, delta S prime squared is equal to 2L squared. And so indeed, delta S squared is equal to delta S prime squared. And we see that, again, that indeed delta S squared, the interval is invariant. Now, I did this for a particular example, particular geometry, but it's completely generalizable to, for example, 3 dimensions. So any two observers that are in inertial coordinate systems moving with respect to each other will see the same, will see this interval as being invariant. Okay. Notice that I didn't have to plug in any numbers here. This was all done in a completely general way, and I could have chosen any axis to do the calculations for. So it's completely generalizable. Okay, let's move on now to see how we can use the invariant interval to gain some insight in special relativity. Let's first talk about proper time. And we've already actually defined the proper time as follows. The proper time, delta ta, is the time interval between two events measured in a frame in which the events happen at the same point in space. Okay. Now, something really important to understand here is that there may not be such a frame. Okay. And we'll see that in a second. That there, I mean, in just a minute or two, that there may not be such a frame. There may be no frame in which two particular events happened at the same point in space. Okay. Okay, but if there is such a frame, then because these two events take place at the same point in space, then delta R squared is equal to 0. Okay, and that means that delta S squared, which is equal to C delta ta squared, is greater than 0. Okay. So okay, and so also C delta ta, the actual proper time, is just equal to the square root of the interval. Okay. Now, it's so whenever we have a positive interval, whenever the value of the invariant interval is positive, that means that we can define a proper time. Okay. And the proper time is just the square root of that interval. That's it. So that actually is pretty useful. That already allows you to do, if I ask you what's the proper time, if I give you two events that may not happen at the same place, I can still ask you what the proper time is for those two events, for the interval between those two events, because you can, in principle, if this is positive, you can boost to a frame that's moving in which those two events happen at the same point in space. And since the interval is invariant between two different frames, you can, even without figuring out exactly what that velocity of that boosted frame is, you can still calculate the proper time because you just take the square root of the invariant interval. Okay, so just to kind of say that again, if delta S squared is greater than 0, then that implies, by the definition of the interval, that C delta T squared is greater than delta R squared. We can rewrite this as delta R over delta T squared is less than C squared. And so what we see is that this is basically just, this right here is just the velocity of a frame. Well, it can be the velocity, it has units of velocity, and so we can define it to be the velocity of a frame, and if it's less than C squared, then that means that the interval is greater than 0.